This video covers square roots of perfect squares with signs. So we say if n is even and a is positive or 0, then the nth root of a is the principal nth root of a. And we say that negative nth root of a is the negative nth root of a, right? So if I wanted the square root of 4, that would give me 2, right? But if I want to get the negative nth root of a, then I'm going to put the negative symbol out front. We simplify what's under the radical. We kind of treat it like a grouping symbol or an exponent. That would give me negative 2, right? This is how we're going to distinguish between whether we want the positive or negative root. It's important to note in case 2 that if n is even and a is negative, then the nth root of a is not a real number. It's actually a complex number. We aren't going to worry about those right now, but you'll see them later in your math classes. So if I have the square root of negative 4, this number does not exist. Well, 4 is not a real number. So it does exist, but it's not a real number. Let's put it that way. Why is that? Well, if I take two negatives, I can get a positive. If I take two positives, I can get a positive, right? If I take them multiplied together. But there's no way that I can get two things multiplied together to give me a negative, especially two things that are the same, right? Two things that are the same, so I could get a perfect square. That's not going to happen. So the square root of 100 is 10. The negative square root of 100 is negative 10. And the square root, I think I meant to have a negative in there. And the square root of negative 100 is not a real number. Let's do a few more examples. Here I have the square root of 121 is 11. The square root of negative 81, it's really tempting to say negative 9, but this is not a real number. We cannot take the square root of negatives. And negative 64 is negative 8.